We are looking on slide number 2 at this party that you're having, right? So the budget in this party is represented by the variable B dollars. Okay, we're spending the B number of dollars on appetizers. Okay, you plan to order V number of vegetarian spring rolls that cost 75 cents each, and S number of shrimp rolls that cost 95 cents each. The equation 75 cents V plus 95 cents S is equal to B. This represents the constraints in this story. So we must, so when might it be most handy to use each of these equations in the party planning? AKA, what does each equation below tell us? So when you're looking at which of these variables is isolated, I want you to tell me when would we use that? Like when we use that, what would we be solving for? So you're looking at these isolated variables and you're deciding when would you use each one of these equations, okay? So I want you to take a minute right now to decide when would you use each one of these equations in what scenario, okay? Let's get started. Awesome. We're taking another 30 seconds for each of these to decide when would you use each of these equations? What do each of these isolated variables represent? And then when would you use it? Okay, I'm going to pull up the chat and let's take a look at what people are thinking for when we would use each one of these. Okay. So I didn't have any friends sort of lets me know in the chat what they were thinking. So what I'm going to do is oh, okay, perfect. So Dylan said that for number 1, he would use this one when we're trying to tell what the total budget is. Yes, Dylan, very good. So when we know the number of the veggie rolls and the number of spring rolls, we would use this equation to solve for the total budget of the story. Very good. I would use this when looking for the total budget. Budget is one of those words. B-U-D-G-E-T. Perfect. Okay. Now, when would we use this V is equal to equation here? And what does the V represent? When we're solving for V is what Julia said, but what does the V represent? I forgot. You want to unmute, Julia?
Yeah, it's solving for the number of vegetarian rolls.
Yes. Yes, so good. Nice job. So we would use this when we're looking for or solving for the number of vegetarian spring rolls. Nice job. Okay, so we would do that when we know our total budget. So to solve for these V's here, we would need to know the total budget and the number of the shrimp spring rolls. Good. So then when we're looking at this S1 here, so when we're looking for, when would we use this S is equal to B minus 0.75 V divided by 95? Yes, nice job, Meryl. When we're looking for the number of the shrimp rolls. Yes, Meryl, awesome job. When we would use this when we are looking for or solving for the number of shrimp spring rolls. Shrimp, S-H-R-R-I-M-P, spring rolls, S-P-R-I-N-G-R-O-L-L-S. Mr. Main has to think about her spelling. Nice job. And we would get that by dividing the total cost by the spring rolls, right? So the vegetarian spring rolls times the price, and then we would divide by that price of the shrimp spring rolls. Yes, nice job, Jaden. I mean Jason, sorry. Jason Derulo. Anyways, nice job on that one. So when we use these different equations when we're looking for different things. And when you're looking at an equation and it asks you, when would you use this scenario? When would you use this equation? Is when you're solving for that isolated variable. So when we're solving for the total budget, when we're solving for the number of spring roll or for the vegetarian spring rolls, when we're solving for the number of shrimp spring rolls, okay? So that isolated variable is what you're solving for when you're given an equation, okay? So our I can for today is I can write and rewrite equations to solve for a particular variable using real world problems. So we're doing the same exact thing that we were doing yesterday, where we are isolating different variables or solving for different variables in order to find total different pieces of information in our story, but this time we're going to be talking about real world problems. Yesterday we did talk about some real world problems, but today we're going to go even more into that idea of real world problems and using really big numbers. So just be prepared. I would say probably get a calculator out for yourself. So maybe grab your phone for a calculator. If you have an actual calculator, that might work for you as well. Okay. You might need also a piece of paper for yourself too. Okay. So today, here is the story, the scenario that we're dealing with. Okay. So the Department of Streets of a city has a total budget of $1,962,800 for resurfacing roads and for hiring new additional workers. Okay. So they have a total of $1 million to resurface roads and to hire additional people. The cost of resurfacing a mile of two-lane road is estimated at $84,000. The average salary of a worker at the department is $36,000 a year. Okay. So the first thing that you need to do, you're taking 1 minute right now, once I get through explaining, is you're writing an equation that represents the relationship between the budget, the amount of the mile long road that you're resurfacing, and the new people that you are adding. So I want you to write an equation right now, comparing the two-lane road that they could resurface, M, the number of new workers that they could hire, P, if they spend the entire budget. You're taking 1 minute right now. Go ahead. Nice job, Melina Main. Ooh, Claire. Yes, girl. Nice job, my friend. Awesome job. We have another 29 seconds. Claire, it's looking great. I know I already said that, but I saw it and it just caught my attention. Nice job. Let's see what other people are thinking for equations here. Okay, so the problem with that, Landon, is like sometimes the Chromebooks can't handle a bunch of things running at once. So my suggestion to you is make sure that you go into your internet, close out all your tabs other than your PowerPoint, and just keep the Zoom and the PowerPoint open, okay? And then what would that be? Awesome. Okay, so let's come together and let's take a look at some of these equations that people are getting. Okay. Awesome job. And Landon, if you just want to listen for today, if you want to watch the video later, you can if there are pieces you want to look at. I'm going to speak everything out loud. So there's nothing that I'm going to just say like, hey, look at what I just wrote, and then you have to look at it. I usually say everything out loud anyways. So if we're looking at this equation here, we can write it like this. I'm going to pull this box over a little bit because it is a little bit longer. So we're talking about that budget, which is $1,962,800 is equal to, so 84,000 times the number of miles of road that you're going to be, just like Dylan said, times the M miles of road that you're going to be doing, plus we're adding in that number of new people times their salary. So it's going to be 36,000. Make sure that you're putting the correct number of zeros here, my friends. 36,000 times the P number of people that we hire. Okay? So make sure that we check these. Like, for example, Dillo and Julia, you were missing a few pieces of it. So make sure you go back and you get these. Eric, that is cool that you use those different variables. That works. Just make sure that you sort of make that connection later on when I ask you to solve for P and M, okay? Okay, so perfect. So you could have also written it. Nice job, Meryl. Fantastic job, Meryl. Woo! Okay. You could have also written it as 84,000 M plus 36,000 P is equal to 1,962,800 because we maintained equity by switching these and keeping all of our signs the same. Okay. So you can write it like this. That is 100% correct. I would 100% take that on an assessment. Okay. So I'm going to go through here and I'm going to actually just get rid of this extra one because I want to just have one that we're going to focus on. So now we're going to use this equation right here, and you're going to do two things on the next slide. This is where the piece of paper is really going to come in handy, okay? And making sure that you're writing things in parentheses. If you're going to be dividing by a number, make sure that you're writing things in parentheses for this. So now you're going to you're going to take this equation that we just wrote on the last slide here. Let me copy and paste it, Control copy, and we're going to paste it on here. We're going to take this equation and we are going to isolate now for P, or solve it for P. Then you are going to solve it for M. You're going to do two different solvings here. And then after that, you're going to tell me when would you use each one of those equations. I would use this solve for P equation when I'm looking for, I would use this solve for M equation when I'm looking for what? You're taking 2 minutes right now. Actually, I'm going to give you 3 minutes actually to isolate so isolate for P, then isolate for M, and then tell me when you would use each one of those equations that you isolated for, okay? You're taking 2 minutes right now. I'm going to be sending messages to people, so just be aware. Okay, I sent a message to a friend. Make sure you're checking your chat and letting me know. Perfect, okay? So let me know if you need anything, okay? Let's start to see some equations in the chat. Make sure if you're talking about, so for example, we're talking about maybe dividing by some number, make sure that that first piece is in parentheses, okay? Just for sort of yourself. Awesome, awesome, awesome. Okay, so then yes, Claire, that's perfect. You can simplify by getting on the left side there. If you get rid of that divide by the 36,000, that simplifies to just a P. But yes, that's perfect. The right side is perfect there, Claire. Rock star, rock star. Okay, we're taking another minute and 16 to isolate for these different equations here. Ooh, Fizza, nice job. You're missing your variable though on your 84,000 Fizz. Yes, nice job, Haley, that's perfect. You have that variable. I like the parentheses around that little bit. Nice. Do you see what I'm saying there, Fizz? Awesome job, Claire. Yes, Claire DeLune is on a roll today. So, okay, so you don't have to simplify, like you don't have to actually do the division. You just leave it as a fraction of that numerator over that denominator. You don't have to actually do the division out, Julia, because you might not get a whole number. So you wouldn't divide by the 36,000p. You want to get the p by itself. So how do you isolate that p, Luke? You divide by just the 36,000. Okay, that's okay, Luke. Just try your best, okay? I mean, Aiden, sorry, Aiden. Okay. So, ladies and gentlemen, awesome job. My suggestion to you when you're solving this is I would start off with that first equation of 1,962,800 is equal to 84,000 m plus 36,000 p on a piece of paper. So what I'm going to do is I'm going to stop my share for a second and I want to sort of show you how my paper looks. So on a piece of paper, I wrote it out. Okay. So then my next step of what I need to do next is I need to first, I'm trying to isolate this one for P. So I need to move that M piece, that whole thing over to the other side. And the way that I do that is by moving a whole piece together, I either do addition or subtraction. So for this one, because it's a positive 84,000, I would subtract 84,000 M from each side. And I would be left with 1,962,800 minus 84,000 M is equal to 36,000 P. Okay, so it would look like this. Okay, and from there, you guys can see me, right? Let me see. Yes, you can go to the bathroom. So then to get there, you have that P, that 36,000 is attached to the P through multiplication. So you would divide by 36,000, divide by 36,000, and it would look like this. Okay, and you would be left with P is equal to 1,962,800 minus 84,000 M over 36,000, or divide by 36,000. I would leave it just like this. When you are typing it in your document, you're going to put parentheses around the whole numerator, and then you can use the little division sign and then just write. So you would write that whole numerator and then the 30 divide by 36,000. Okay, so that's how you would write it. Let me go back into the document and let me show you how you would write that. Okay, so let me share my screen. So we would be left with P is equal to, in parentheses, 1,962,800 minus 84,000 M, all divided by 36,000. Okay. So then if we looked at the next one here, where we now need to isolate for our M, we would have to sort of do it the opposite way. We would have to move that 36,000 P over to the left side and then divide by the 84,000 to get that M isolated by itself. So we would be left with M is equal to parentheses 1,962,800 minus 36,000 P, all in parentheses, divided by that $84,000 per mile that it would cost. Okay, So these are my two equations here. This is how I suggest that you write it in, just because it is a little bit tricky to make fractions here. We don't have that cool tool that helps us write fractions yet. So does anyone have questions on how we got and isolated these two equations to get these two new equations to solve? No? Okay, perfect. So now we're going to use these equations to calculate some values, okay? So now you're going to use these two equations to, on number 6, slide number 6, you're going to solve 4 different values here. You're going to solve for 4 different values. So which equation first, which equation would you use to find out how many miles of 2-lane roads it could resurface? So which one of these equations here? The original, A, or B, to solve for the number of miles that I can pave? The original, A, B, or A or B? Nice job, Claire. Nice job, Julia. What do we think, guys? Which equation will help us, or is the easiest to solve for the number of m miles? Nice job, Jessica, Brianna. Nice job, Aiden. So let's see, Fizza. Hey, Fizz, can I have you unmute and tell me, why did you think that B would make it easiest for us?
Because if you're trying to find the value of m, you need to solve for m, and equation B solves for m.
Very good. So if we know that P number of people that we hire, it's going to make it much easier for us to plug some values in and solve it, right? So we're going to say B because it's solving for, Command V, because it's solving for M. Okay. So when you're looking for an equation that would best help you, you're going to pick the equation that has that variable isolated or all by itself. That letter, the equation that you're solving for that variable. Okay. So we're going to skip B here, and we're going to go right down to slide number 7. Okay. Slide number 7, you're going to be using these two equations down here, A and B, to solve for 4 different values. How many people can you hire if the department is resurfacing 16 miles of road first? Then how many can you hire if we are resurfacing 3 miles of road? Then the second section, you're going to use a different one of the equations, and you're going to say how many miles of road can we resurface if we hire 2 new workers, and if we hire no new workers. Okay, so I want you to use those 2 equations from 5, going step by step. Don't type the whole thing into your calculator at once. Do it step by step and calculate these 4 values here. Okay, so you're taking 3 minutes right now to solve for these 4 values. Okay, here we go. Put questions in the chat. Okay. Definitely go one step at a time here. Awesome job. We're taking another 2 minutes throwing answers in the chat once we're getting them. Awesome job. We're taking one more minute, my friends. So think about logistically, if you're getting decimals, can we get decimals for some of these? Can we not get decimals for some of these? What are we thinking? We're taking 52 more seconds, my friends. Let's start to get some answers in the chat, my friends. How many people can we hire? Just let's look at the first box. If we do 16 miles of road, what did you get for that first one there? What did we get for that first one there? Okay. Okay. Awesome. I'm seeing a lot of different answers here, my friends. So I'm seeing some 18s, I'm seeing some 17s, I'm seeing some 18.18. First question. When we're talking about the number of people that we can hire, what kind of numbers are we going to be dealing with? Whole numbers, yes. Some whole numbers, perfect. So we have to have whole numbers. So we're not going to have any decimals. So when you solved it, when I solved it, I got 17.19 when I rounded, or when I rounded it to the nearest hundredth. So if I have 17.19, what would I round that number to? Would I round it up to 18 people? Julia, Julia said no, we wouldn't round it. Julia, why do you think we wouldn't round it up?
I don't think that we could round it up because then we wouldn't have enough money to pay them.
Exactly, right? So we're talking about a budget and we can't go above this budget, right? So that means I need to round it down because I don't want to, if that 17th person that I hire or that 18th person that I hire isn't going to have enough, we're not going to have enough money to pay him. So we're not going to be able to round this guy up. We're going to have to say it's equal to 17 people here. Okay? Because we can't round it, we have to say it's going to be 17 people because we have to round it down. P-E-O-P-L-E, people. Oh, Mr. Main. P-E-O-P-P-E-O-P-L-E. Okay. What about our next one? When we pave 3 miles of road, how many people are we going to be able to hire? What did we think here? Nice job, Julia. Think about that rounding again. Melina and Claire are both saying 47 people. Melina, do you mind unmuting and tell me why did you say 47 instead of 48?
Because I rounded.
And why did you round it down? Because it was 47.52. So I would have thought like rounding roller coaster would make me go up. So why did you go down?
Because I don't know.
Because we can't, if we get 48 people, we're not going to have enough money to pay that 48th person all of his money. So we need to round it down so that, I mean, we're going to have a little bit of extra money left over, but that's better than not having enough. Okay. What about if we hire 2 new workers? How many miles of road can we pave? What did we get for this one here, guys? This one, think about, can we do decimals for this? Thinking logically, can I pave like half a mile? Yes, we can. In this one, we can use those decimals. Good. And like Claire said, we would be paving 22.5 miles of road if we were to hire 2 new workers. Very good. So we can do decimals for this one. So we would say 22.5 miles of road. What about if we hire 0 new workers? How many miles of road can I pave then? What did we think? Almost there, guys. A little bit too big there, Claire. I think your decimal is 1 place over. How many miles of road? Let's see what people think. Nice job. 23.37. Very good, Julia. 23.37 miles, because we said we can do decimals. I think your decimal is one place over, Melina. I think it's supposed to be 23.3. Nice job. We could say 23.37 miles, or we could round it down to 23.3 miles. Awesome job. Awesome job, my friends. You guys are so super fantastic. You don't need to do anything with B on slide number 6. Your afternoon work for today. All of the time is built into the video, so you're not spending any time outside of the video. So when you look at it, it's 30 minutes long, but that's literally the amount of time that you need to do it. If you're taking more than the 30 minutes, then you're going to be stopping and you're going to be going out and playing in the snow or doing whatever you need to do. So this video is, you're going to follow along with these slides here. Okay, I go through slide 10 and 11 with you, and then you're taking 10 working minutes to go through 12, 13, 14, and 15. Okay. So what I suggest, if it doesn't run when you're in a different tab, I would maybe open a different window. Or you know what you can do, if it's still, like, if you can't open it in another window, that's kind of weird that you can't, but whatever. Well, it's not a big deal. So you click on it, and if it 100% doesn't work, down in the bottom corner here, it says the YouTube, but I want you to try to watch it through Edpuzzle, because that's where my grade is mostly going to come from.
Yeah, because here's the Edpuzzle, what makes you watch the video. So like, you can't go into a different tab because they don't want, but like the easy way is just make a new window. It's like, it's like,
That's-
what's the point of making it so you can't go in another tab when you can just make a new window?
See, that must be something, I've never run into that before. So maybe that's sort of like a new thing that they did. So what I want you to do to get past that is you grab the tab, right? And you pull it into its own sort of window like this, and then you snippy snappy. Well, I can't really snippy snappy because I'm on a Mac right now, but you snippy snappy and do half and half and watch as you're working in another window. Okay. Does that make sense?
Yep.
Both of you guys, thank you for bringing that to my attention. I didn't realize that that was a problem. So maybe I'll put a post on our other classes streams about it. Okay. Okay. Awesome job, ladies and gentlemen. I am so immensely proud of all of you today. If you're working this afternoon and you have any questions, please send me an email and I can reach out and help you out. Okay.
All right. Bye. Have a nice day.
I don't know what we're doing for tomorrow, but